Hi, good morning. It's Thursday morning. We're going to quick go over the homework. We're not really going to learn anything new today, but I'm going to recap what we did with the metallic bonds yesterday. And then for the homework, I want you to review, or excuse me, finish that review sheet that we'll go over right now. Okay, so I wanted you to do 2 and 3, section 2 and section 3, and for tonight just to finish that last part. So let's blow this up a little bit. And we will also pull up the periodic table. Okay, which atom is more electronegative? Right, its symbol. So we have a choice here. Now, you had a worksheet from a couple of weeks ago, anyway, probably 3 weeks ago, that had a chart on the top of it, on the back of the sheet, that showed the individual electronegativities. You could pull that up if you would like, or I can post another. I'll try to find that and post it. But you could also use the idea that anything that's closest to fluorine is going to be the highest. So let's take a look at that. Fluorine has the highest electronegativity at 4.0. As you move away from that, it's going to get less. So if you don't have your chart, we can rely on that. Let's look. Bromine or chlorine? Well, chlorine is closer to fluorine, so chlorine has the higher electronegativity. Sodium or magnesium? Sodium and magnesium. Well, sodium is actually bigger than magnesium, even though magnesium has one extra proton. Remember that as we go from left to right, the size of the atoms actually goes down. So it's also closer to fluorine. So magnesium is the one to go for. Lithium or sodium? Lithium or sodium? Well, lithium is smaller, and because it's smaller, it's going to have a greater electronegativity. Remember, the general trend is as you go down a group, electronegativity goes down because the atoms are getting that much bigger. So lithium is the one to choose here. Nitrogen or oxygen? Well, in this case, oxygen is smaller. Because it's smaller, it's going to be able to pull electrons more, and it's closer to fluorine. So we're going for oxygen here. And fluorine versus anything, it's always going to be fluorine. Okay? Second part of this is, are there polar bonds in these, right polar or non-polar? Well, we have to see if there's a difference here between the ion or electronegativities between carbon and chlorine. Well, chlorine has quite a bit. I think that's about 3.7 electronegativity, and carbon's over here. So this is going to be a polar bond. Carbon dioxide. Here's carbon, here's oxygen. The difference here, if you were to look it up, would be fairly high. I don't have this in my head. I think this is about 2.1 maybe, and that's in the 3 range. So this does contain polar bonds. And oxygen, well, if we have 2 oxygens, they have the same electronegativity, and since they have the same electronegativity, one is not pulling on the electrons more than the other, so that's nonpolar. Well, this is a little bit more challenging. I've got carbon in the middle, and then I've got 4 fluorines around. Because of that, and each of these is the same atom of fluorine, each of these is pulling on the electrons from carbon at the same strength. And because of that, we say it's nonpolar. Remember, polar means that there's more pull on the electrons of one atom compared to the other ones. HCl. Here's hydrogen chloride. Well, we just saw chlorine. Chlorine is right next to fluorine, so it's got a pretty good electronegativity. That means it's going to pull the electrons away from hydrogen, making this side slightly negative and this side slightly positive. So this is a polar molecule. And then N2. N2 is put together with a triple bond. Since we have two of the same atoms, they have the same pull. And if they have the same pull, one isn't overpowering the other one, so this is a non-polar molecule. Okay? So all I want you to do is finish this for your homework. And just very quickly, we will recap. Two things we hit yesterday were molecular substances. Remember, molecular substances are put together by covalent bonds. They're covalently bonded. They are soft, not brittle, compared to ionic substances. They don't conduct heat or electricity very well. Not sure what happened. And then they have relatively low melting points, and there are some examples there that are covalently put together. And then the other part that we learned, hopefully you looked at that clip, is that metallic bonds, basically you've got atoms surrounded by electrons that can go wherever they want. And each of these atoms is going to contribute a couple of the one or two electrons that go in and are, I can't draw on here, but can flow wherever they want. That's why this is referred to as a sea of mobile electrons. Okay? That's why also that they are excellent conductors of heat and electricity. Okay? So finish that for homework, and we'll see you tomorrow.